Yes, so what we will do, I will let you know. Motion of a charged particle. Let me just put it in the first line. Motion of charged particle. Yes. So the magnetic force would be equal to the centripetal force. Because the motion is circular and we have the situation that let's say here is the center and here's the charge, here's the center, and the motion is, say, somewhat circular. It makes a radius r, and the tangential velocity would be v. Linear velocity would be tangential, and basically we know that the centripetal force is equal to mv squared by r, square velocity multiplied by mass divided by radius, and we know that the magnetic force is equal to vqb. Yes. So here the assumption is the sine theta is roughly is equal to 1 because theta is equal to 90 degrees. So here we have this theta, see, which is in case of tangential linear velocity 90 degrees. Okay, so sine theta is 1 and v is qvb. So we equate the two. Mv squared by r is equal to vqb, and mv squared is equal to vqbr, and we're looking to estimate the velocity, but not just the linear velocity. And so we put v is equal to r omega. Linear velocity is equal to radius times the angular velocity. So m r square omega square is equal to v q b r. R reduces its degree because we have another r on the other side of the equation. So omega square becomes v q b r by m r square. Omega becomes v q b by m r under the root. Yes, so this is interesting. Once again we let me just make a small alteration and then we will do it in a simple way because this is complicating the situation. So let's do a little bit of a trick here, which is mv dot v is equal to vqbr. V cancels out. Mv is equal to qbr, and since we know that v is equal to r omega, so mr omega is equal to qbr, and QB is equal to mr omega by r. Okay, so QB is equal to m omega. Yes, so omega, the angular velocity, is equal to QB by m. So we resume with this generalization, which is 3 here, and we know from mechanics that omega is equal to 2 pi by t, so we use it here. 2 pi by t is equal to QB by m. So t in this case will become 2 pi m by QB. Very simply, this would be t, and for f, uh, this implies that 1 by t is equal to QB by 2 pi m, and this would be equal to f. Yes, so f is equal to QB by 2 pi m. Charge, magnetic field, 2 pi, mass. Pi is 3.142 is within the equation. Okay, so now for electron, we estimate the charge to mass ratio. Yes, so once again, the centripetal force equal to the magnetic field force, and centripetal force equal to mv square by r, and magnetic field or related force equal to qvb. Okay, in this case we have this first one, mass of electron, velocity of electron square by radius 1, and second case we have the charge on electron, the velocity, and the magnetic field in the atomic situation. So we equate the two. MEV square R is equal to QEVB. Charge to mass would become QE by ME, the ratio, and would be equal to V square by BR. Okay, so this becomes the third form which we are looking for. Velocity by magnetic field multiplied by radius. So that is very much the charge to mass ratio. And if we are to estimate the velocity, which is also important, the linear velocity, for that we have to do the estimations. The kinetic energy is equal to 1 by 2 mv square is equal to 1 by 2 mev square. In this case, this would be a, and in terms of charge and voltage, potential, it would be q naught QE V, charge, in terms of charge and potential. Yes, so this would be B. So 1 by 2 mv square would be equal to QEV. Yes, so ME, so V square would be 2QeV by ME. The charge to mass ratio lies within, and 2 times the voltage, 2 times the potential, sorry. V is the potential. So you see, if we simplify, it becomes 2V QE by ME under the root. This is velocity, this is potential, this is the form we are looking for. So we also know that we have established this, that QE by ME in case of electron is equal to V by BR. So we can make a substitution, and 2V dot V by BR, this will become the velocity, where this is the potential and this is the velocity. Small v is the velocity, capital V is the potential, B magnetic field, R radius. So this is the form, velocity with another substitution. So let's just make it a little more understandable. So once again, QE by ME is equal to V by BR, and V is equal to 2V QE by ME under the root. Potentials, velocity. So this small v is velocity, and this capital V here is potential, as we know, because it's not being reduced in the degree. So V is equal to 2V dot V by BR under the root, under the root. Once again, 2V by BR under the root, two V by BR under the root dot V under the root. So we're left with V under the root here, and 2V by BR under the root here. Yes, so V becomes equal to 2V by BR. Is it what we're looking for? Somewhat. So this is an interesting equation. This is the velocity, this is the volt potential, and this is magnetic field, this is radius. So